In section 8.2, I'm going to be showing you how to solve systems of linear equations with three variables in this case. Okay. Now, on the only method that we're going to be utilizing for the three equations, three variables, is basically going to be the addition method that I showed you in section 8.1. So, first of all, we're going to talk about a linear equation in three variables. Basically, it's an equation in the form ax plus by plus cz equals d, okay, in which all those numbers a, b, c, and d are numbers that are not necessarily zero. So there could be some zeros, but not all of them are zeros, of course. Okay, there could be some zeros involved. Now, one thing is about how do we express a solution for a system of linear equations with x, y, and z. The solution of a system of linear equations in three variables is called an order triple. Order triple meaning the following. So order triple means x, comma, y, comma, z. Okay, so the only method that we're going to use on this section would be the method of addition. So I'm going to explain that process again as we go, which we already did previously. So before we go into that method, we're going to determine if this order triple is a solution of the system, just like we did in section 8.1. How do we find out if this negative 3, 4, 4 is a solution of the system of the three equations? Well, just like we did on the section 8.1, we need to substitute these values back into all three original equations and see if it is true on each one. If it fails to be true on either one, then we automatically say that it's not a solution to the system. So, first equation, x plus 5y equals to 17. We already know that x is negative 3 and the y is 4. We don't have a z in this equation, so the z is 0, so we don't need to substitute that for z. Z equals 4 in that one. So x is negative 3 plus 5 times y, which is going to be a 4, equals to 17. That gives me negative 3 plus 20, and negative 3 plus 20 gives me a 17. So right here we get 17 equals to 17, so that means that this triple, it is a solution to the first equation. Now, let's check for the second equation. The second equation is 9x plus 7y equals 1. This is my x and this is my y. So we're going to replace the x with the negative 3 here, plus 7, and the y with the 4, equals 1. So that's negative 27 plus 28, and negative 27 plus 28 is 1, and 1 equals 1 is also a true statement, meaning that the triple negative 3, 4, 4 is also a solution to the second equation. We just have one more to test. 2y plus 2z equals to 16. So to test the last equation, we need to replace the y with the 4, this is my y, and the z with the 4 as well. That's my y and that's my z. We don't have any x here, so I don't need the x. So it would be 2 times y, which is 4, plus 2 times z, which is 4, must equal to 16. So it's going to be 8 plus 8, and that gives me a 16. 16 equals to 16, that is also a true statement. So, since this solution is, since this triple is a solution to all three equations, then we can conclude, remember this means therefore, negative 3, 4, 4 is a solution of the system. And that concludes the first part. This is basically, once again, how we check if a given number, if a given point or triple is or is not a solution, by plugging in the values and determining if it gives you a true statement or not. Okay. Now, we're going to be solving systems of linear equations with three variables using the method of addition. So, I'm going to do this problem first. We're going to solve the system. If there is no solution or if there are infinitely many solutions, so state. So, the very first step in the process of this method is that we need to decrease the 3 variables to 2 variables. So basically we are going to construct 2 equations. Out of those three equations, we're going to construct 2 new equations that contain only 2 variables. That's what we need to do. So what does that mean? That means that I need to get any 2 pairs of equations from these 3. So I chose my first and my second equation as my first pair, and I'm going to select the second and the third equation as my second pair. Now it can be also the first and the third equation. Just remember, you have to pick any 2 pairs of equations. So I pick the first and second and third. Those are my 2 pairs. So what your job is going to be is this. Using the method of addition, you need to pick 1 variable and you're going to eliminate that 1 variable from both pairs. Because what we're trying to do is we want to come up with 2 new equations that contain only 2 variables, not 3. So let me pick one. So I'm going to go ahead and eliminate the z's from both of these. So if I want to eliminate the z from the first pair, there's a 1 here, -1. So can I make it a -3, which is the opposite of 3? Yeah, definitely. So all I have to do is multiply this equation by 3 so that this becomes a -3 and it cancels out with the 3. Right. What about here? That's a -1. Can I make it the opposite of the opposite of -4 is 4. Can I make the -1 a 4? Definitely. So all I have to do is multiply it by -4. And that's going to give us the first part. So right here, if I multiply this one by 3, we're going to get 3x plus 9y minus 3z equals to 24. And then we're going to add it to this other equation, which is 6x minus y plus 3z equals -17. Then you can add these 2 equations together. So 3 plus 6 is going to be 9x. 9y minus y is plus 8y. And then the 3z's cancel, equals to 24 plus -17. That's going to be a 7. Now we're going to do the same thing here. -4 times x is -4x. -4 times 3y is minus 12y. -4 times -1z is positive 4z, and that equals to -4 times 8 is -32. Now I'm going to add that to this equation. 3x plus 3y, okay, then minus 4z equals to 15. So if we add them, what are we going to end up with? -4 plus 3, it's going to be -x. -12 plus 3, it's going to be minus 9y. And the z's cancel, equals -32 plus 15 is -17. So that was the first part of the process. You need to pick any 2 pairs of the 3 equations, and you need to eliminate the same variable from the 2 pairs. Now, your next step in the process is that you're going to put these 2 equations together. So I have 9x plus 8y equals to 7. I'm going to put it together with -x minus 9y equals -17. And your job right here is going to be to eliminate another variable from those 2 that we have left on those 2 equations. So we can pick whichever. So let's say we want to eliminate the x's. I believe this is the easiest one. What do I need to do so that they become the same number in opposite signs? So that's already a negative. So can I make it a -9? Yeah, by multiplying this equation by a 9. So if I do that, then we're going to get 9 times -1x is -9x. 9 times -9y is minus 81y equals, then we're going to multiply the 9 times -17, that's going to be -153. And then we need to add it to this equation here. So the 9x plus 8y equals to 7. So when we add them right here, what are we going to get? Negative 9x plus 9x, it cancels out. Negative 81 plus 8 is negative 73y equals negative 153 plus 7 is negative 146. And you see that that gives us basically the y. So all I got to do to leave the y by itself is divide both sides by negative 73. So that gives me y is equal to 2. We already found the first answer. Y is equal to 2. But we're missing 2 more because the solution in this case is going to be x, y, and z. So we already found the y, we need to find the x and the z. Now, anytime you find the first variable, to find the second variable, Burley, you need to substitute this first answer back into one of the 2 equations that we got from the 2 pairs, either this one in blue or this one in red. I call those the middle equations. So you have to substitute it first in one of the 2 middle equations to find the second one. So either one that you pick is going to give you the same result. So I'm going to go ahead and pick this one. Negative x minus 9, and we already know what the y is. The y is a 2, and that equals to negative 17. That gives me negative x minus 18 equals negative 17. I need to add the 18 to both sides to leave the x by itself. So that gives me negative x equals to positive 1. Then I have to divide both sides by negative 1 to get rid of the negative. So x is equal to negative 1. So now we got what x is and we know what y is. So we need to find the third variable, which is the z. So to find the second one, which was my x, I replace the first one back into one of the 2 middle equations, either one of these 2. Now, to find the third variable and the last one, we need to substitute both x equals negative 1 and y equals to 2 back into either one of the 3 original equations. So that's where we need to go back now. So I'm going to use the one in the middle. Okay, the one in the middle says x plus 3y minus z equals to 8. That's the one I am going to use. So we already know that x is negative 1 plus 3. We already know that y is 2, so it's 3 times 2 minus z equals to 8. So that gives me negative 1 plus 6 minus z equals to 8. I can combine these. That gives me a 5 minus z equals to 8. So to solve for z, I need to subtract the 5 from both sides. That gives me negative z equals to 3. And then I divide by the negative 1 to get rid of the negative. So z equals to negative 3. And so that concludes this problem. So then we can write the solution. The solution for this system of linear equations is going to be the order triple. Negative 1, which is my x, comma, 2, which is my y, comma, and negative 3, which is my z. And that concludes this problem. Remember always that if you want to check if this solution is correct, what you can do is substitute the x, the y, and the z with the negative 1, 2, and negative 3 back into all 3 equations to see if all of them are true. If they do, then that means this is the correct solution. Now, we're going to solve another system next. The next system that we're going to solve is going to be this one right here. Solve the system. If there is no solution or infinitely many solutions and the system's equations are dependent, so state. So, we're going to, again, on this system, we're going to pick, usually we should pick 2 pairs of equations, but this one has a little shortcut that we can use. If you notice, the first equation here, it is already missing one of the variables. Remember that the reason for picking up the 2 pairs is to eliminate one of the 3 variables, but in this case, the first equation, the y has been eliminated, basically, so the y, there is no y. So I can take it as if the y was eliminated. So I'm going to use that first equation as one of my middle equations. So, and the only thing I have to do is, you see that this one is missing the y. I'm going to get the other two equations, the second and the third, and that as a pair, and I'm going to do the process of eliminating the same variable, which is the z, from both of them. It's missing the z, so I want to eliminate the z also from these two. And that's going to be half of the work, because all I have to do is one pair. I'm going to use this as if it was the answer from the other pair already. So let's eliminate that same variable that is missing here, which is the z. Okay. What the question is, what do I need to multiply so that the z's cancel out right here? Nothing, because they're already a -1 and a +1. So all I got to do is add these two equations. So the z's cancel, so you're going to be left with 3x plus 3y equals to 6 from that equation. And now you see that we have two equations right here. The one that I extracted from the first one, right, that I put there, and this one that we created. Both of them contain only x and y. So that's half of the work. So now what we're going to do is we're going to put these two equations together, and we're going to eliminate one more variable from those two equations that we got. So let's see which one is the easiest one to eliminate, and I would say it is the y. So if I want to eliminate the y's right here, what do I need to multiply so that the two y's cancel out? In other words, I need, the bottom one is a 3, so I need a -3 on the bottom. So can I make it a -3? Yes, and all I have to do is multiply it by a -3. So that's going to give me a -12x, a -3y equals a -6. Then I'm going to add it to this equation. 3x plus 3y equals 6. So what happens here when I add them? We're going to get -9x, the y's cancel, equals to 0. And right here, to leave the x by itself, all I have to do is divide both sides by -9, so that gives me x is equal to 0. So that's the value of x from my system of equations. That's the solution for x. Now, how do we find the second variable? Just like I explained on the previous question. You first need to substitute that variable into one of the two middle equations, either the 4x plus y equals to 2 or the 3x plus 3y equals to 6, whichever one you want to substitute it into. So I am going to go ahead and use the second equation. So 3x plus 3y equals to 6. We already know that x is equal to 0, so I'm going to replace the x with the 0 right here. Plus 3y equals to 6. So that gives me 3 times 0 is 0, so that just gives me 3y equals to 6. Divided by 3, it gives me y is equal to 2. So now I already know that x is equal to 0 and y is equal to 2. Now to find the z and the third variable, we're going to go back and substitute these two back into either one of the original equations. Of course, we cannot use the first one because the first one doesn't have z, and we're looking for z. Because remember, we use the first one as one of the middle equations, so that was one of the middle ones. Now, let's use whichever one of the other two. So I'm going to use the one in the middle to find the third one. So it's x plus y minus z equals to 6. We already know that x is 0, plus y is 2, minus z equals to 6. 0 plus 2 is just going to be 2, minus z equals to 6. Subtract the 2 from both sides, so you get negative z equals to 4. Then we divide the negative on both sides, and that gives me z equals to negative 4. And we finished the solution in this problem. We can write it out. The solution for this system of equations will be the order triple, 0, 2, negative 4. And that completes this problem. If you want again to check the solution of this system, remember that you can always go back and substitute this triple back into all the original equations to see if it gives you a true statement or not. Okay. So now for the next question. Now we're going to solve another system of equations with 3 variables. Let's say let's go ahead and find the solutions to this system. So the system, if there is no solution or infinitely many solutions, and the system's equations are dependent, so state. Okay. So on this system of equations, what we have to do first is that we need to fix it because it is not in the form ax plus by equals to c. So we need to fix the system of equations. That would be the first thing. So in order for us to fix it, we need to use distributive property right here to get rid of the parentheses. So for this one, that's going to give us a, I'm going to first try to fix the first equation before we start. So if I distribute this one, that's going to give us a 12x plus 4y, and then we have a plus 5z right there equals to negative 2. So, and that is already fixed. You see it's already in the form, in the standard form, right? Now, the second equation, distribute the 3 times all of these, and that gives you 3x minus 12y plus 9z equals 2. Then you have a 4 on the other side. And last but not least, we're going to use distributive property here. That's going to be 6 plus 9x. Let me work it out right here on the bottom because that one is not going to be fixed. 6 plus 9x equals to, also we can distribute it here, negative 4z plus 16y. And you see that this one is not fixed in the right way, so we need to put the x together with these other ones. So we're going to move the x as a minus 9x to this side. So the equation already fixed is going to look like this. Negative 9x, then plus the 16y, minus the 4z equals to the 6 that is on the other side. I just flip the direction of the numbers. So if I move the 9x, all the x, y, and z will be on this side, but I can just move them to the left. That's okay. So this is a system of equations already fixed. Okay. So now, now that they're already fixed, we're going to get 2 pairs of equations again. So we can say, for example, I'm going to get the first and the second equation from the system as one of my pairs, and I'm going to be getting the second and the third equation as my second pair. And I think the easiest one to eliminate for me at this point is going to be the x's, as you can see. Because on the y's and the z's we need to multiply both equations, so I'm just going to try to avoid that if I can. So right here I can just eliminate the x's easily. So what I have to do is to eliminate this x right here, this x's, I need to make the 3 a negative 12 by multiplying it by negative 4. So that's all I would have to do. To eliminate these x's right here, I need to multiply this 3, to make it a 9, I need to multiply it by 3. So that way it cancels with negative 9. Right. So that's what we need to do. So that's going to give us a negative 12x plus 48y minus 36z equals negative 4 times 4 is negative 16. This other one, 3 times 3 is going to be 9x, 3 times negative 12 is negative 36y, plus 9 times 3 is 27z and that is equal to 4 times 3, which is going to give us a 12. Then don't forget that the next part is that we need to add it to this equation here. So we're going to add it to 12x plus 4y plus 5z equals negative 2. So we're going to add it to this one. So whenever I added it to this one, so it's going to give us 0 for the x, then 52 for the y, then negative 31 for the z, and that equals to negative 18 on the other side. Now for this one, we're going to add it to this equation, to negative 9x plus 16y, plus 16y minus 4z equals to 6. So when we add them together, we're going to get, the x's are going to cancel out again. So we're going to end up with negative 20y, then plus 23z equals to 18. So we got these two equations right here. Now we're going to put them both together, and we're going to eliminate another variable from those two pairs. Okay, from those two equations, I'm sorry. So it's 52y minus 31z equals negative 18. So we're going to combine it with negative 20y plus 23z equals to 18. So on this one, they're equally difficult. So I mean, we're going to have to forcefully multiply both equations, whether we want to eliminate the y or the z. Doesn't matter. So let's go ahead and pick one. I'm going to eliminate the y. Okay. So what I need to do is I'm going to multiply the 20 on the top equation. I mean, we have to multiply both of them in this case. So I'm going to multiply the 20 right here on the top equation, and I am going to multiply the 52 on the bottom equation. And we don't need a negative because they're already plus or minus. So they already have a positive and a negative. That's what we need to multiply here. So if I multiply the 52 times the 20, that's going to give us 1,040. Y. Then the 31 times the 20, it's going to be 620 minus 620z equals, then the 18 times the 20, it's going to give us negative 360. Now we're going to do the same thing for this one. 52 times 20, that's going to be a negative 1,040. Oh, it has to be in this one. Negative 1,040. Y. Then 52 times the 23, it's going to be positive 1,196z equals, then 52 times 18, it's going to be 936. Now we need to add these two equations. So the y's, you see that both of them cancel, right? So we're going to get 1196. If I subtract 620, that's going to be 576z equals to, then 936, if we subtract the 360, that's also going to be 576 on this one. Then how do we leave the z by itself? Divide 576 on both sides, and that's going to give us z is equal to 1. Now, how do we find the x and the y from, given that the z is equal to 1, then first of all, to find the second variable, remember that there's an order. We need to substitute this z equals to 1 into one of the two equations in the middle, either this one right here or this one right here, whichever one you choose to substitute it to. So I'm going to substitute it into this one. Negative 20y plus 23z, but z is equal to 1. I'm going to substitute it with the 1. Equals to 18. So that's negative 20y plus 23 equals to 18. I'm going to subtract 23 from both sides right here, and that's going to give me negative 20y equals to negative 5. And then if I divide both sides by negative 20, That's going to give me y is equal to negative 5 cannot be divided by negative 20, but we can reduce it to 1/4. So the y is equal to 1/4. Now, what happens? Once we find the second variable, how do we find the third? Remember that we need to substitute both of these back into any of the three original equations to find the third one. Now, I wouldn't suggest using these. Let's use the ones that we fixed right here on the right side. So pick one of these three original equations, and you're going to substitute the two variables that we already know back into either one of those three. I'm going to go ahead and use the middle one. Okay, so the middle one says 3x minus 12y plus 9z equals to 4. I'm going to use that one. Okay, so it's going to be 3x minus 12. We already know the y, it's going to be a 1/4. Plus 9 times z, which is 1, must equal to 4. So then we get 3x, negative 12 times 1 is negative 12, divided by 4, it's going to be negative 3. 9 times 1 is going to be 9. So if I combine like terms, negative 3 plus 9 is going to be a 6. So it's 3x plus 6 equals 4. So we subtract the 6 from both sides. That gives us 3x equals negative 2. And then we divide it by 3. So then we get the solution for x is going to be x equals to negative 2/3. That's the value of x for the solution. To finalize this, remember that we're going to write the solution as an order triple. So the solution for this system of equations is x, which is negative 2/3, comma, y, which is 1/4, comma, and z, which is a 1. And this is the solution for the system of equations above. You can always check your solution, like I said, by replacing the values of x, y, and z, which is negative 2/3, 1/4, and 1, back into each one of those three original equations right here, and see if it gives you a true statement on all of them. And this concludes section 8.2.